Okay, so hello everyone. Thanks for checking this video out firstly. Welcome along. My name is Stuart Miller and I'm a PhD cybersecurity researcher here at Queen's in what is known as CSIT, which stands for the Centre for Secure Information Technologies. We are in the Titanic Quarter and CSIT is the largest academic cybersecurity research centre in the UK. This video is the presentation which I gave recently for an event hosted by the Institute of Civil Engineers, and I'm here to talk about the importance of data and cybersecurity in civil engineering, so I'm going to speak about that for 15 or 20 minutes. Hopefully, if you're watching this, you will have heard of some sort of cybersecurity attack or incident in the news in the past month or two, or maybe you have some cybersecurity knowledge. Maybe you're just careful with your data, or you play around with some cybersecurity software, or something like that. Firstly, a little bit more on myself, so you know who I am and what I do. As I said, I'm based at CSIT, researching cybersecurity, specifically in machine learning, which is where computers learn to recognize patterns in data by themselves. I've also studied applied cybersecurity, software development, and business information technology. Also, I would encourage you to keep in touch. There's my email, Twitter handle, and I'm on LinkedIn as well. Okay, let's get into it then. So this is all about data security or cybersecurity in terms of civil engineering. Part of the driver for this was the State of the Nation 2017 report, which the Institution of Civil Engineers put out a couple of months back. And the theme this year was digital transformation. So that includes how data is valued and the impact that has on processes and systems. So what is security? How do we define it? There's a good definition here we can use from the Engineering Council, which states the following. Security can be defined as the state of relative freedom from threat or harm caused by deliberate, unwanted, hostile, or malicious acts. It operates on a number of levels, ranging from national security issues to countering crime. And I would add to that by saying we want and we expect to feel secure. We expect ourselves and our data to be secure at home, at work, in our cars, in hospital, when we're traveling, and so on. As we'll see though in this presentation, that may not always be the case. Smart infrastructure is the combination of physical infrastructure with digital infrastructure, also known as cyber-physical. For example, consider fixed or broadband assets and wireless or mobile assets. Infrastructure can really be driven forward by technology and data processing, though this creates windows of opportunity for cybersecurity attacks as data is gathered, stored, shared across different networks. So ultimately, the civil engineering and cybersecurity sectors need to team up. Belfast has recently been designated as a smart city too, and the council are doing a lot of work on that front as I speak. So smart cars that drive themselves, machine learning, artificial intelligence, and the Internet of Things will change how infrastructure is used. Connected road and rail networks could help someone select the best travel route home come 5 p.m. Already the technology is available to monitor how many vehicles are on a particular stretch of motorway at any one time. And using this, it could be possible, if that motorway was particularly busy, to redirect drivers via some alternative route. A smart energy grid could make use of smart meters to be more efficient with energy distribution. We can use small sensors in infrastructure projects that enable preventative maintenance by live monitoring of asset or component performance, and this prevents service disruption. We could put sensors on a railway bridge, which gives engineers real-time information about the condition of that bridge and lets them know if and when maintenance is required. This technology is needed and wanted as it will make all our infrastructure projects more efficient and make them easier to maintain. However, again, the more we do this, the more our infrastructure becomes more vulnerable to cyber attacks. And we need to consider the threat early enough so it can be mitigated easily and more cheaply. Remember, everything electronic emits a signal which can be interrogated from a distance, and smart devices are never off unless their power source is removed. So thought needs to be given to, the fabric of buildings and how material and equipment is designed. All of this infrastructure activity creates data, And as more people have access to more data, there's a greater risk of accidental or inappropriate information sharing. For example, sensors can share data accidentally, storing data between projects or when they're talking to other devices. If you think about it, major infrastructure projects involve large supply chains, lots of organizations, and lots of people. A good example of dependencies between physical and digital infrastructure is the Lancaster flood of a couple of years ago, which caused high impact damage. Electricity was cut to over 60,000 homes, properties, businesses, schools, and hospitals, and some had complete fixed line and wireless telecoms blackouts, no contact at all. These schools and hospitals closed, heating and cooling systems for housing and food were offline, and electronic payments were impacted too. All that was from natural causes, but a cybersecurity infrastructure attack can do the damage too, as we shall see shortly. Smart, connected assets place demands on digital communications and energy infrastructure. The next stage of connectivity is what is known as the Internet of Things, where pretty much any electronic device or sensor you can think of will be online. It's estimated there will be 500 billion devices connected by 2030. Big data needs big power too, and the UK expects to treble its output in the next decade. Having all this data creates vulnerabilities, and hence being cybersecurity aware has to be the status quo in civil engineering. Cyber attacks come in many different forms. They can be state-sponsored, say a group of hackers working on behalf of government, trying to find out another country's secrets, for example. And cyber attacks can come from other places too. Someone who's not happy in their job, didn't get that promotion, or some teenage hacker who downloads some tools and launches a cyber attack from their bedroom at home. Some attacks don't require a large amount of technical know-how. It could be that software is not updated for a while. Even giving open access to Wi-Fi is dangerous. And sometimes it can be as simple as a building management team not changing a password from its default settings, so in essence the building can be accessed by anyone. Distributed denial of service attacks, or DDoS for short, are a fairly recent form of cyber attack and are becoming more commonly used. Essentially, the network of an organization is flooded with data, meaning the organization cannot function, and so the hacker can hold the organization to ransom. Keep in mind, no network is 100% secure, and organizations have different levels of maturity in their cyber defenses. The UK government takes cybersecurity very seriously and recently launched the National Cybersecurity Centre, a division of GCHQ that is like a new nerve centre to manage cyber incidents. And so responding to this government advice, creating and adhering to good practices, policing people as well as your supply chain will all reduce your risk of cyber attack. Now let's look at some examples of cybersecurity attacks and incidents. We could have a new sensor-driven system for monitoring speeds of trains, their energy efficiency, the operational status of the lines, and also monitor where passengers get on or where passengers get off. This all generates data and is very vulnerable to attack. Also, Stuxnet was a malicious piece of software coded by the US and Israel in an attempt to damage Iran's nuclear program. It infected a nuclear plant in Iran via a USB stick, and then it spread, changing the speeds of the machinery that separated nuclear material, and that caused a lot of substantial damage. In the US, there have been hospitals that have had their systems compromised, forcing them to revert to paper records. No email access, patients being turned away, surgical operations were affected. Only a matter of time, if you ask me, before this happens in the UK. Let's see what happens. Malicious software could be embedded into the system of a crane that's being delivered to some sensitive construction site. That crane needs to be connected to the site's network in order to allow it to communicate back and forth with its manufacturer and supplier. And so the malicious software could infect the network and compromise the data. And lastly, Chinese researchers were able to interfere with a Tesla car's brakes, door locks, and other electronic features, demonstrating an attack that could cause havoc. So cities like Belfast are becoming smarter. People, places, spaces, buildings, infrastructure, and devices are all becoming connected to one another. Of course, smart cities need resilient power supplies and distribution, or else we get taken offline. We know that civil engineering infrastructure connects customers, businesses, education, healthcare, and it links us together as people. So this means, however, there's a lot of scope for cyber attacks like these ones. Those last set of examples show that when a physical asset is procured, there's data for that same asset that needs managed securely too. This infrastructure data has significant value, of course. In fact, there's an argument that says if that data contains information that lets us identify individuals, it may even be more valuable than, say, the credit card details of those individuals alone. Also, in about a year's time, the European Union's General Data Protection Regulations, or GDPR for short, along with the Network Information and Security, or NIS for short, directive come into force. GDPR strengthens the rights of data subjects. The penalties are like 4% of a company's global revenue, or 20 million, whichever is the greater, being opposed. Those are much, much bigger than they are currently. The NIS directive is designed to ensure critical IT systems in core sections of the economy, like energy and transport, are secure. And so infrastructure owners and operators will need to make sure that they are prepared for the enforcement of these new regulations. If you're working on a project where you are dealing with or collecting or storing data on individuals, I strongly urge you to visit the Information Commissioner's Office online and read their guidance. This includes getting a proper understanding of the Data Protection Act, the Human Rights Act with regard to privacy, and also thinking about a privacy impact assessment, which is an excellent framework to make sure you consider sensitive personal data thoroughly and reduce the chance of your company being involved in a scandal further down the line. As engineers, I can direct you lot to some engineering council guidance that feeds into this next part, which is advice really for you guys. This will help you identify, assess, manage, and communicate issues about cybersecurity. Let's look at these then. Number 1, adopt a cybersecurity-minded approach to your professional and personal life. That means be aware of your behaviour and your use of social media. Consider threats to people, your assets and systems on your project, and sensitive information. What is vulnerable that could create a security breach? Be asking yourself that question all the time. Security risk assessments can be undertaken, and there are tried and tested ISO standards for these. If things change, or if a new asset or system is put in place, or something's being used or integrated in a different way, do be responsive to that. Number 2, show a commitment to privacy, reliability, and ethical conduct. That means encouraging others, empowering them. Make sure if you're reporting to someone or if someone's reporting to you, that cybersecurity is considered. Number 3, comply with the law and seek professional advice. Be aware of the data protection and cybersecurity related laws in the country you work or where your products and services will be used. And do not lie. Number 4, engineers should protect sensitive information when it's being communicated and stored inside and outside of the organisation. Be aware that what goes on the internet stays on the internet forever. So take care what you publish. If you put project or technical or personal information online, it will aid cyber attackers doing reconnaissance without question. And be aware of social engineering too. Everyone's had those emails you get from, a rich prince in a far-flung country asking, can he or she transfer you money? They are the tip of the iceberg, and you will get some that will be very specific to you and very specific to your company eventually. Lastly, number 5, contribute to public and professional awareness of security. Do engage in debate on data and cybersecurity risks. Do be security minded during public discussion. Be honest, be clear. If you're not sure about something, again, don't lie or bluff your way. If you're involved in a project where there's clearly a threat of cyber attack, or you think there may be one, you need to be aware of it. So speak to an expert, get advice. If you were taking legal or medical advice, you'd seek out a qualified professional. And so I'd urge you to do the same with regard to data security, cyber threats. So finally, I'd just like to finish up with my contact details again. That's just about it. Would love to hear from some of you. Thank you very much.